So today we're going to jump back into the structure of an atom, specifically the structure of a nucleus, and talk a little bit about isotopes. So before we discuss that, let's talk about one of the fundamental rules of chemistry. So chemistry, like all sciences, have a lot of rules, but most of the rules have exceptions, and we spend a lot of time studying those exceptions. However, this is one rule that has no exceptions. So this is one of the few times that we can use the word all. So all atoms of a specific element have the same number of protons. Okay? So that is how we define a certain element. Okay, so something like hydrogen. So hydrogen is always going to have one proton. Any atom that only has one proton is hydrogen. Helium has two protons. If it doesn't have exactly two protons, it's not helium. So that is how we define what type of element an atom is. So the number of protons we also call the atomic number. Okay. So if I ask you what is the atomic number of an atom, I'm also asking you how many protons does the atom have. So those two words are used pretty interchangeably there. So then, after atomic number, another term that we use to describe atoms is the mass number. Okay. So mass number is the mass of a single atom in AMU. So we look at only the number of protons and neutrons here, and we assume that protons and neutrons have a mass equal to 1 AMU. So I can say that mass number is equal to the number of protons plus the number of neutrons. So we remember that electrons have a very small mass relative to protons and neutrons, so we ignore those here. It is important to note that mass number is not on the periodic table. And we'll discuss why in a little bit, and we'll discuss what mass actually is on the periodic table. Okay, so we've already said that all atoms of a certain element have the exact same number of protons, but all atoms of a certain element do not have the exact same mass number. So that must mean that atoms of an element can have a different number of protons, and that is correct. So we call these isotopes. So isotopes are atoms of an element with different numbers of neutrons. Okay. So let's take carbon, for example. So carbon, by definition, always has to have 6 protons. Okay? If it does not have 6 protons, it is not carbon. So carbon can have different numbers of neutrons. So let's say one carbon atom has, we'll say 6 neutrons. So if a carbon atom has 6 protons plus 6 neutrons, its mass number is 12. We simply add together 6 plus 6. So I can have another carbon atom. Again, it has to have 6 protons, we know that. Let's say it has 7 neutrons. So if a carbon atom has 7 neutrons, its mass number is 13. So we could say 12 AMU or 13 AMU. So both of those are carbon atoms. Okay, they're same, they have the same chemical properties, but they have different masses. So we call them isotopes. So they're simply the same type of atom that has a different mass due to a different number of neutrons. So there's a couple of different ways that we show this. So we know the symbol for carbon is a capital C. So let's just describe the two isotopes of carbon I described here. I could write carbon 12, or I could write carbon 13. So that is one way to notate the mass number of a certain atom, and we call this the nuclear notation. Another way to write it it's called the hyphen notation. So I write out the name dash the mass. So carbon dash 13. I call this the hyphen notation. So both of these are equivalent. They mean the exact same thing. Whether you write carbon 12 like this or like this, you mean the exact same thing. It's just two different notations that we use. So if I know the identity of an atom, so let's just say lithium, for example. When I know an atom's name, I automatically know the number of protons. So if I have lithium, we'll say 6, for example, could I use this information to determine the number of neutrons? And hopefully you see yes that we could, because the mass number is equal to the number of protons plus the number of neutrons. So in this case, the mass number is 6. The number of protons in lithium is 3. So I don't know the number of neutrons, but then I can do some simple algebra here, and I see that the number of neutrons equals 3. So in this case, in this particular lithium atom, I have 3 protons and 3 neutrons in the nucleus. So you might be asking, well, how do you know that lithium has 3 protons? So let's go to the periodic table and let's just look at lithium, for example. So we'll draw out the box you might see for lithium. So you probably see something that looks like this. You see a 3, then you see something like 6.94. So there's always going to be 2 numbers. They're not always necessarily going to be arranged in the same fashion on the periodic table. They can be flipped. This is the most common orientation though. But how do we know which of these is the atomic number? And so there's a simple way, there's actually 2 ways. The smaller of the 2 numbers is always going to be the atomic number. So let's talk about the atomic number. So hopefully you remember the atomic number is simply the number of protons. So it's always the smallest number. So we'll say smaller of 2. And if it's simply the number of protons, it always has to be a whole number. So we can have 6.94 protons, so the atomic number is always going to be the whole number on the periodic table. Okay, so now you're probably thinking, what in the world is that number with a decimal then? So that number is actually the atomic mass. It is not simply the mass number, it is the atomic mass. So the atomic mass is the average, we'll say, of all naturally occurring isotopes. For an element. So we saw up here that carbon could have a mass of 12, it could have a mass of 13, or it could have different masses. So we can't just write 12 or 13 on the periodic table. We instead have the average of all the naturally occurring isotopes. So again, remember, isotopes have different masses but the same number of protons. But it's not just a simple average that we calculate. In a few minutes we'll discuss how we actually calculate the average atomic mass. But for now, just be aware of the difference between the terms atomic mass, which is the average number we find on the periodic table, versus the mass number, which is what we use for a specific atom, and it's never a decimal number, because for that specific atom we have a set number of protons and a set number of neutrons that we combine to get that. So one other thing that we need to discuss really quickly is we haven't really talked about how to determine the number of electrons yet. Okay? So we know that electrons are so light that their mass isn't counted in the mass number. And we know that the atomic number tells us the number of protons. We really have no way of looking at electrons. So we can make a note here in neutral atoms. The number of protons equals the number of electrons. So that makes sense. If protons have a positive charge and electrons have a negative charge, if the atom is neutral, meaning it has no charge, they have to equal each other. So neutral carbon always has the same number of electrons. It always has 6. So down here, neutral lithium would have 3 electrons. So we'll discuss later on how to find the number of electrons when atoms are charged, when they aren't neutral, but it's a pretty simple process. So now let's look at this table in our notes and try to use the couple of pieces of information we're given to give a more clear picture of each of these atoms described. So notice on my paper, I left off a few of the pieces of the information that were in the notes chart because we don't need them, we can find them on our own. So let's look at the first one, helium-4. So the first thing we have to ask ourselves is, what does that -4 mean? So we know in hyphen notation, the number after the dash is the mass number. So the 4 tells me the mass number. So I believe in your notes, the atomic number was already written in. But let's pretend that it wasn't. How would I find that? So I could pretty easily go to the periodic table, find helium, find that its atomic number is 2. So we automatically know that the atomic number is equal to the number of protons. So those are equal. It doesn't show helium having a charge, so we know the number of protons is equal to the number of electrons. Okay? So then we know that the mass number is equal to the number of protons plus the number of neutrons. So I know in this case that 4 minus 2 is equal to 2 neutrons. So the nuclear notation, I could write He4, or I could write helium-4. Okay? So it just so happened here the number of protons, neutrons, and electrons are the same. For very small, simple atoms, that's not an uncommon trend, but as atoms get larger and more complex, that won't be the case. So don't always make that assumption. So next we have carbon. Okay, so let's go ahead and look at what we have. Treat it kind of like a little game. It doesn't matter what order you go in, you just have to fill everything out, get all the information filled in. Okay, so for carbon here, let's look at our information. We have the mass number as 14. So I can go ahead and fill this in here. I can write carbon 14. And it actually is more common to see the mass written on the left side in the nuclear notation. So go ahead and put it on the left side. You'll see it sometimes written on the right like I have here, but we typically write the charge over here. So let's go ahead and make the habit of putting the mass on the left side. So how do I find the atomic number for carbon? Yeah, that's correct. Hopefully what you said. You go to the periodic table, you see the atomic number for carbon is 6. We know atomic number is always equal to the number of protons. For a neutral atom, protons equals electrons. And we know that the number of neutrons is the mass number minus the number of protons. So here we have 8 neutrons. Okay. So for the next one we have boron. This 11 tells me the mass. So I can go ahead and write boron 11. Or I can write B11. But then I need to know what the atomic number is. So how do I find the atomic number for boron? I go to the periodic table. I find that it is number 5. So I know it has 5 protons. It is neutral. So protons equals electrons. Then I can do 11 minus 5 and determine that there are 6 neutrons in this specific boron atom. It doesn't mean that all boron atoms have 6 neutrons, but in this particular case, this atom does. So then silicon, we have silicon 29. So I can fill in 29 as the mass number. I can write silicon 29. I can write Si 29. Hopefully you have learned your chemical symbols by this point. So I know that the atomic number for silicon is 14. I can get that pretty easily from the periodic table. So I know the number of protons is 14. The number of electrons in this case is 14. Then the number of neutrons I can determine pretty easily by the mass number minus the number of protons. So in this case I would have 15 neutrons. So I'll leave the rest to you as practice. They should be pretty simple, but let's talk really quickly, about how to determine the number of electrons for an atom that has a charge. So we calculate the charge of an atom by the number of protons minus the number of electrons. So when they're equal, charge equals 0. Okay, so we're good. But if we have a charge of plus 1, that means there is one more proton than there is electron. If we have a charge of negative 1, that means there is one more electron than there is proton. So let's look at an example of lithium with a positive charge. So you'll see it written a couple of ways. You can see lithium plus, you can see lithium plus 1, you can see lithium 1 plus. Okay? So this positive or negative number is a superscript on the right side, refers to the charge. And I apologize up here, I shouldn't have written the nuclear notation on the right side. Go back and change in your notes and always put the mass on the nuclear notation on the left. I shouldn't have done that. So we see here, all three of these are equivalent. They're all perfectly okay to write. So we see this lithium has a charge of positive 1. So I can plug in the formula and say 1 equals the number of protons. So if I look on the periodic table, the atomic number for lithium is 3. So it has 3 protons minus the number of electrons. Okay, so I can do pretty simple algebra and see that the number of electrons is equal to 2. So lithium with no charge would have 3 electrons. Lithium plus 1 would have 2 electrons. So let's look at one more example. Let's look at oxygen. So oxygen, if it has no charge, would have 8 electrons. And that's simply because the atomic number for oxygen is 8. So if there is no charge, the atomic number, the number of protons, equals the number of electrons. But we often see oxygen with a negative 2. Or you'll see it written a 2 minus charge. So in that case we can use our formula and say negative 2 equals the number of protons, which is 8, minus the number of electrons. Okay, so you do your algebra and rearrange, and you see that the number of electrons is equal to 10. So oxygen with a negative 2 charge has 10 electrons. Okay. So hopefully not too difficult. If you get confused about that, just stop and think. Okay, for an element or an atom to be negative, it has to have more negative charges than it has positive charges. They can't cancel each other out. So I have to have more electrons than I have protons. So when you get done, just double check yourself. This oxygen atom had an overall negative charge. The charges didn't cancel each other. So there has to be more electrons than there were protons, which is what I got, so I'm probably correct. For lithium, it had a positive 1 charge in this case. So there had to be more protons than there were electrons, which is what I found to be true. I found there are 3 protons and 2 electrons. So you can always go back when you finish those and do kind of a simple logic check just to make sure your answer makes sense there.